We can hear you, sir.
Hey, how are you? I responded saying, okay, a quick review based on what we did the last meeting. And from our next meeting, every 30 minutes to the end, we'll use that minute for Excel application. So I'm not going to continue today with the Excel. Excel, that content is very lengthy. So every meeting except today, 30 minutes, 30 minutes is assigned to that session of your course. Any question based on what we did the last meeting? As I'll start from topic 2.1. I'll give you about a minute. Any question? We are through with topic 1. Yes or no? Have you finished topic 1?
Yes, sir.
Good. And the last meeting, we did the last topic, which is the Excel also. So I continue. Okay, then we continue. At the end of this session or topic, they should be able to understand and identify concepts of, you should be able to understand, identify, as well as describe the various components associated with microcomputer or microcomputers. This topic will go through all this. You should be able to be familiar with the key components such as memory and then the processor. First, I start this 2.1 CPU or the central processing unit. We have already discussed this, and you are aware that the CPU is the main component in computing or microcomputer that converts all activities into a meaningful things for you. So before you can convert data into information, it's a job of the CPU or the processor. This CPU is a chip, like normal phone chip, a small component that consists of collection of compressed electrical circuit. The CPU small component consists of compressed electrical circuit, and this contains millions of transistors. So CPU, just a small component, consists of millions of transistors that support you to convert data into information. And this integrated circuit or transistor is also called chip or microchip. So in computing, when you hear chip or microchip, it's the same as CPU. It's the same as the processor. The CPU is like human being, the heart, and is the heart of the computer. And put in mind that the heart of a human being takes decisions. Whether the hand must raise up, whether you have to walk with your leg or whatever. So the CPU is the heart of the computer. And there are some components also associated with this CPU. It is built in various forms, and then PC or microprocessor or microcomputer system, the name, as I said, can be called chip, microprocessor, or whatever. But in a bigger system, like supercomputer mainframe, the main component that convert data into information is called circuit board. Bigger computer system, component that convert data into information like super mainframe computers called circuit board. But in our microcomputer system, the component that convert data into information is called CPU chip or processor or microprocessor. Good. The CPU can be present in various forms and always placed on the main component or a component in computing called motherboard. When you open the system unit, the main case, there's a board there that contains all the electrical components of your computer system. Within that board is where you have the CPU. So the CPU is always located in the main board or motherboard of a computer system. The job of the CPU is to execute instructions or execute software instructions. When you switch off your machine, the software like Word, Windows, they are all saved on your storage device like hard disk or any other means. Moment the computer is switched on, this software is in a language, machine language form, in code, and before you can put in a Word environment, Windows executable environment, is a job of the CPU that convert instruction, software instruction into a usable form for you. So the job of the CPU is to convert data into information, one, and two, to execute software programs stored or saved on a storage device like hard disk. So put in mind that once you switch on your machine, it's a job of the CPU that convert everything on a storage device into a meaningful thing for you. The figure here shows how the CPU works. The CPU is here, central processing unit is here. It has two main components, control unit and arithmetic logical unit. I've explained to you that there are three things you need to consider, or three key components you need to consider when buying or selecting a computer. One is the storage, which is the hard disk. Secondary storage hard disk example. Then the next one is central processing unit, which is the CPU here. Then the last one is the memory. These are the three key things that justify the capability of your computer system. And then the CPU is here. Once anything is entered from the keyboard, that is input data here, it goes to the machine, straight to the memory. The memory here will decide, what do you want to do? I want 2 + 2. Then the CPU takes over, convert this data into information, before finally to the output. The job of the CPU here also to convert what you have stored on the hard disk here into a meaningful form for you to understand. These instructions are executed in the machine language. The machine language are zeros and ones, and these instructions on the computer system always converted into this before it appears into a meaningful form for you. The CPU, as I said, has two main components. One is called control unit, normally called CU, and another one, arithmetic logic unit, ALU. The control unit here is like the brain of a computer. From the onset or beginning, I said CPU convert data into information. Now, you have understood that the CPU divided into two main components. One is control unit and another arithmetic logic unit. The control unit part of the CPU is like the brain of the computer. Now, it is the job of the control unit that convert data into information. It's a job of the control unit that give instructions to other units to perform. The control unit, as said, can be compared to our brain. And then the job of this control unit is to instruct other components in a computer system to perform their jobs. So if you want to save something on a hard disk, it's a control unit that instructs hard disk to save something or open something from the hard disk. If you want to print from a printer, it's a control unit that will instruct the printer to perform that job. And the job of the control unit is highlighted below. As you can see in the figure here, the job of the control unit is to direct all the units in the computer system to perform their job. More specifically, the control unit does not, again, it does not execute any instruction in computing, does not execute any specific task in computing. It does not execute any instructions in computing. The job of the CU control unit is to give direction to the component to perform their job, but does not perform any practical action in computing. I said the CU is like human brain. You can never use your brain to carry your laptop. No. But you instruct the hand to carry the laptop. You can never use your brain to eat. You instruct your mouth to eat. So the CU as a component of CPU does not execute any practical job or instructions. It just gives or informs the component to do their work. The CU here coordinates and control all the computer activities once instruction is received from the user. Once you give any instruction, it's the CU that coordinates and control all these things for the job to be done for you. It's a CU that directs movement of data between memory and arithmetic logical unit or arithmetic logic unit, and also between input and output devices or memory and input-output devices. So you should note that the CPU is divided into two main components, CU and ALU. It's the ALU that directs all the components in a computer system to perform their job. The CU itself does not execute any instruction in a computer system. It's like the human brain, as I said. So if your computer CU is not working, then your computer will not work. Because human being, if the brain is not working, it's unlikely that it can work. You can perform the job well. In other words, the CU instructs all the activities, decode this to its purpose, and then ALU to perform that job. So we have seen that the CPU divided into two main CU, ALU, and CU give instructions to other components to perform their job. The CU itself does not perform any practical job. Now let's see the ALU as a second component here. It performs mathematical operations, arithmetic operations, and logical operations. So the CU here, all the mathematical operations in the computer system are performed by the CU, by the ALU. The ALU performs two operations. One is the logical operation, and another one mathematical operation. So all the mathematical operations, all the arithmetic operations in computing are performed by ALU. Put in mind, all the logical operations in computing and mathematical operations or arithmetic operations are performed by ALU. So now, you should know that a component in computing that converts data into information is ALU. We have explored the CPU. We have seen two main components. CPU consists of ALU and CU. Now you have understood that the component that convert data into information, that perform arithmetic logical operation is ALU. It perform basic arithmetic operations such as addition, division, multiplications, compare operations. You can say that, for example, student result. If your result is equal to 50, pass, else fail. If your result is greater than 50, pass, else fail. So those comparison to compare, if not this, it should be that. That comparison is done by arithmetic logic unit. Then the last one here is logical operation like such as and, on, if not this, or this and that. Such logical operations are done by ALU. So ALU performs these logical operations, arithmetic operations in computing. So you should know that now we have gone to a different level. Not the CPU as we learned from beginning that convert data into information. Now we have explored the CPU. And you have seen that in CPU, there's a component called ALU. ALU perform the operation or logical operation and arithmetic or mathematical operations in computing. Are we okay here? Are we okay?
Yes, sir.
Yes, sir.
Okay. Good. Have you seen this? The one I've highlighted. Someone
Yes.
should read for me or read for us. After read for us.
Explain the interaction between CU and ALU with a practical example.
Good. So we can try this. Explain the interaction between the two key components in CPU with a practical example. Who can try this? Do you understand this question? If you don't understand, let me explain it further. Do you understand it?
No, sir.
No,
A
sir.
little.
No, sir.
Do you understand it? Yes, no.
No, sir.
Okay. Explain the interaction between the two. First, you need to define what is called CU. The next one, what? ALU. Then after that, you explain how these two components work together. Then you give example. Do you understand the CU?
Yes, sir.
Do we understand the CU?
Yes, sir.
Okay, so tell us your understanding of CU.
So, sir, so
Mhm.
for for my simple understanding,
Yes, I'm waiting.
for the managing operations,
I didn't get to
managing of operations
Okay.
inside the CPU.
Okay, inside the computer system.
Yes.
The CU manages operations inside the system unit or inside the computing. Good. What about the ALU?
So, sir, to explain that,
Is Bernard who just spoke?
sir, it's Philip.
Philip. Okay. Okay. So another person. Ernest, let me hear you.
Operations as well. So,
Ernest, let me hear you about CU, the ALU.
okay, so the CU direct
I
data
can't hear
into,
you.
say the CU. Can you hear me?
You are telling us ALU.
Oh, okay. The ALU performs logical operations and mathematical operations.
I could not hear you well.
So I said the ALU performs logical operations and mathematical operations
Arithmetic
as
and
well.
logical operations. I will give that. Performs arithmetic and logical operations. Are you okay? Good. And then the other one say explain the interaction between the two. So who can try that? I gave you forum for discussions. Only three of you took part, and I responded to them accordingly. So I'll post this as an assignment. Do you get me? This one is assignment for you. Do you get me?
Sir,
Philip.
please, sir, please, the forum. I've been trying to contact Mr. Justice,
Mm-hmm.
but I'm not be able to get to him. Even this morning, I called him, but he's not picking. About the
So
forum, we are not
mhm.
able to access the forum, and we cannot see each other's comment because the one that you said they sent to you directly, and we are not seeing it. We can't see it.
Okay.
So
So if I send assignment also, you can't see assignment
okay,
or
so
that.
the assignment, if you put it on the comments, then we will see it, and then you can open it, then we can do it, and then submit it to you on the LMS.
Okay. So assignment, if I put assignment, that one you can.
And
You
so
can get assignment.
unless you put it, then we see.
Hmm.
Because what you posted, we saw it, and some of us we did it, but
But you could not get it.
send it to you, then we can send it like how the others do. Send it to you direct, like chatting. That please, but it is not in the forum that we can reply to each other.
Okay. Okay. So I'll put it in the assignment. Is there an assignment you can see it? So have you done some assignment before?
Yeah, that is the first one that you say our colleagues submit to you directly.
Okay. And that approach, you can easily do it.
Yeah, so if we should do it like let me, I don't have, I can just forward mine to you direct.
Okay.
By the way you said, it's good that we interact. If somebody give a comment, you also can see and then comment on it. If there's something that is interactive. But if we send it to you direct,
Hmm. Okay, I was trying to check, but it looks like the approach is the same thing. Okay. Then can you solve this problem when I give you as assignment?
Okay, sir. Okay, sir.
Can you solve it?
Sir, what I have to do, I have to still contact Mr. Justice.
No, not that is what I'm looking for. I say, can you, if I use it as assignment, do you understand it? Can you?
Yeah, I can do it.
You are saying, yeah, you can. What about the rest? Can you solve this question?
Yes, sir. Yes, sir.
Yes,
Okay,
sir.
that is
Yes,
great.
we can.
The next is microprocessor. Now we have understood the microprocessor. We have two techniques or two types of microprocessor chips. Two types. So I'm starting from here. The two types are, one is called SIC, which means compressed instruction set computing, and another RISC, reduced instruction set computing. This means before any manufacturer or developer will come out with computer-related product, you need to consider these two types of architecture. The sixth, which means compressed instruction set computing, is a type of computer architecture, and this involves large number of instructions before something is executed, and normally classified as hard coding. So the sixth is a compressed instruction set architecture, and this type of computing architecture involves large number of instructions before something can be executed. And this type of architecture has become popular by Intel microprocessor technology. So if you have any device, you switch on any machine, then you see Intel. That means that technology is compressed instruction set computing. And this Intel short name is I. So if you see i7, i5, I this, that means it uses the Intel approach. This means that any expert in the field, before you can develop or manufacture any product that can be compatible with this type, you need to understand the template, understand the policies or the framework involved. Before, when you come out with any product, you can work with the six context or the six architecture. Then the next is reduced instruction set computing. Also, another architecture in computing, this type involve few instructions, whereby the other one is large instruction to execute something. Here, less instructions or few instructions to execute something. Its design is simpler and cheaper than the SIC. And this normally, this involves small set of instructions for each coding approach. An example is what we see here. If a computer uses with a processor with this term Pentium, that means it uses what is called the sixth architecture. PowerPC, Alpha MIPS also uses what is called reduced instruction set computing. So if your computer is Pentium, put in mind that the architecture is called SIC, complete instruction set computing. Now we have understood the processor as a key component of computing. The next one is memory. The memory, another name for this memory called primary storage, main memory, or system-oriented storage. So in computing, when you hear primary storage, main memory, system-oriented storage, volatile memory, they refer to this type of memory. The memory is separated from the CPU we have seen together, but the two work together. You can't separate the memory from the CPU because anytime something is entered from the keyboard or input device, it goes to memory, memory decide where it must go. So the two work together, but they are separated. Everything inside the computer system needs to be present inside the memory before it can be accessed by the CPU. The memory here, as long as it's on, hold your work temporarily. But when power goes off, everything is gone. So it stores our work temporary as long as the power is on. The storage space, the memory storage space, gives us 5 functions. So 5 functions associated with memory storage. 5 functions associated with primary storage. 5 functions associated with main memory. 5 functions associated with volatile memory. 1. Provides environment for operating systems or system software to be loaded and also act as an interface for this system software to link with the hardware and application software. So the first one, you are saying that the memory provides environment for system software to be loaded and also provide an interface for application software such as Word, Excel to work with hardware components. When you switch on your machine, everything is gone. Moment you on it, the memory is loaded. The memory provides space for Windows to be loaded. And once Windows is loaded, it also enables it to link to application software and then the hardware components. The next function of the memory storage provides space for application programs to be loaded or to be used. Before you can work with the internet, Excel, CorelDRAW, WhatsApp, the memory provides space for this application program, which by default store on the hardware, store on the hard disk to be loaded into executable form for you. So put in mind that before you can run Excel, Word, the memory supports set program to be executed into a form or a usable form, a form that appears to your language for using it to suit your needs. The next one, provide storage for data. Moment you type something from keyboard, you are typing something from keyboard, doesn't mean that it's stored permanently on the hard disk. No. The memory provides temporary storage for anything input by the user. Memory provides temporary storage for anything input by the user. Also provides temporary storage for anything retrieved from the hard disk. When you retrieve maybe your file you have saved from the hard disk, it goes to the memory. When you enter something from the keyboard, it goes to the memory. So the memory hold work loaded from the hard disk, work performing by the user temporary as long as there is power. The memory also supports you to save something to the hard disk and also retrieve something. The memory supports to save something to the hard disk or storage device. When we are saving something onto the user storage, the memory is called system-oriented storage. Other storage devices are called secondary storage or user-oriented storage, such as pen drive, CDs, hard disk. It's a job of the memory that supports you to save something onto the secondary storage, such as pen drive, hard disk. Again, provide space for programs that are running or data when required. When you switch two or more programs, the system apportion space automatically. For example, you have opened CorelDRAW, which is a very big file. Then later you open Excel, smaller than the CorelDRAW. It's possible that Excel can open before the CorelDRAW. And after this job is done, the memory automatically assign additional space to the CorelDRAW so that one will be loaded. So memory add additional space when it's needed. And these are the 5 functions of the memory space. The memory and the processor communicate through what is called bus. And the bus is a component in our field that connects devices, internal devices together. The bus here is like a lane, the road that connects one town to another, that connects one city to another. So before you can move from one town to another, you pass through a road, a lane, a bus. In our field, before the processor and memory can communicate, they communicate or they talk through what is called bus. The bus is the path that links various devices together. And this is how the bus looks like. There's a bus here. See the number of lines. These are the bus line or the lanes. They connect different devices. So assuming there's one device here, another device here is the bus that connect them together. So put in mind that a component that connect the various devices in competing for data movement, for signal movement, for instructions is called bus. A component in competing that connect the various units, various elements to communicate through signal, instructions, data is called bus. 3 types of these bus. One called address, data, signal or control. Address bus, this type is always driven by the processor. So it's one way by the processor. Processor uses that one to perform instructions. So address bus is one way driven by the processor. Then data bus, driven by the processor for write cycle, but memory take the read cycle. So this is not one way. Memory and then the processor use this bus. Memory use it to read, and then processor use it to write. Data bus is where processor use to write something, memory used to read something, signal, data, instructions, or whatever. Then control or signal, this type of lane or bus determine whether the system must read or write, when to start data validity, etc. Signal control determine which one must write, which one must read. So these are the 3 types of buses in competing. We are still in the memory. The memory here consists of 3 chips. Memory has 3 chips. Memory has 3 types of chips. One is called read-only memory, random access memory, and chip metal oxide semiconductor called CMOS. And this spelling is different from my name. So chip metal oxide semiconductor called CMOS, read-only memory called ROM, random access memory called RAM. These are the 3 types of memory chips. We have 3 types of memory chips: RAM, ROM, and CMOS. What we have been talking about memory is this, the main memory. The RAM is the main memory. The RAM is the main memory that holds your program instructions, And this is the one that communicates the CPU. The RAM means read only, but today there is a technology that combines RAM and ROM together. And this technology is called flash memory. So flash memory is a technology of RAM, which is read-only memory, and ROM, which means permanent storage. That's why pen drive, you can store your work on it permanently. Again, you can edit the content of your pen drive. So, a technology that combines RAM and ROM, example is flash memory. And this is how memories are measured. Memory are measured. In computing, memory and then the hard disk or storage device are measured in bytes. So bytes is what we use to measure storage capacity in computing. But the processor performance is measured in hertz. Hertz, H-E-R-T-Z, hertz. The memory, that is the primary storage and secondary storage, are measured in bytes. And this is how things are measured. The memory capacity, we have kilo. Kilo means 1,000. But in computing, it doesn't mean exactly 1,000. It's 1,024. So there's a reserve of 24. And this 24, I said reserve, is meant for the system to keep extra or give you extra space in case the 1 kilobyte, which is 1,000, is consumed by you. So if you have a storage device which is 1 kilobyte, the maximum space you can use is 1 kilobyte, which is 1,000. And then there is a reserve of 24. This means that when the user consumes the whole 1 kilobyte, and without this reserve, then the system will not work. Let's see your room. You have packed things for the entire room. You will not be able to move from one place to another. So the system always reserves space. In case you consume the maximum given to you, then that space is a reserve that can support you to maneuver, move from one place to another. Without this reserve, when you consume the space assigned to you, then your computer cannot work because there will be no space to move. From kilo, which is 1,000, we have mega, million in that order. Also, you see the space added. Then giga, terabyte, and petabyte. So these are the storage capacity. Today, if you buy anything, computing device or storage device measured in kilo or megabyte, means out of date, cannot handle today's programs and files. So anything measured in kilo, megabyte means too small to handle. It should be in the form of gigabyte and terabyte. The RAM here, as you see, the RAM is the main memory that holds your work temporarily as long as there's power. The RAM here has two divisions, two types of random access memory, one called dynamic and another one static. The dynamic, we stand for, which is dynamic read only, random access memory, short for DRAM, holds your work in a dynamic way. Everything you put in a system does not store permanent. Instead, the computer refreshes itself 100 times every second. So the dynamic is the part of memory that refreshes the system for new input. If there's no dynamic, then when you press anything from the keyboard, you have to wait until that one is processed, finished process, before a new input, finished process. But here, You can type a lot of things from the keyboard, perform a lot of jobs simultaneously. But as you are doing the system refresh itself, the memory refresh itself 100 times every second. That's the DRAM. So dynamic refresh the memory 100 times so that you can input anything you want. That's why your computer system can put a lot of things in the memory. You can put a lot of things, type a lot of things simultaneously because the dynamic refresh the system 100 times so that new input can be performed. And then the other one is called static. This part of the RAM holds your work as long as there is power. So when you are working, for example, what you can see on the screen now occupies static. When you are working, you type anything, you load something, that job occupies what is called static. The static hold your work permanent as long as there is power. So put in mind that there are two types of RAM. Dynamic refresh the system 100 times every second for new input to make possible. Then dynamic. This hold your work as long as there is power. So put in mind that when you are working, as you can see, your work is showing display on the screen. It occupies what is called SLAM, the static random access memory. I hope we have understood this. We have understood this?
Yes, sir.
Good. I want your comment on this. I'll explain that microprocessor chip, we have two types. RISC. The memory chip consists of three types: CMOS, ROM, and RAM. And then the RAM also consists of two types: SLAM and DRAM. Okay, let me finish up to the CMOS here, then ask questions. Then the next type of memory chip is the ROM. ROM means read-only memory. Program built in a factory by the manufacturer, which cannot be erased by the user. It always gives you details about who manufactured that product. So this ROM chip, I said, contains program from the manufacturer, and the content cannot be erased by anybody. If the content can be erased by someone, the moment you manufacture your keyboard, moment you manufacture any component of yours, somebody can go there and change that he or she is the owner. But here, no, nobody can change it. So when you switch on your machine, the component or detail that always display to show available things and whatever, always inside the ROM, can never be erased by anybody. Your phone, the one who manufactured it, some informations are there. Such information can never be erased by anybody. And they are inside what is called ROM chip. ROM chip. There are different types of the ROM. Example, PROM means programmable read-only. EEPROM, erasable programmable read-only memory. And then practical examples also are there. Then you can see the flash memory also here. The flash memory is part of the RAM at the same time ROM. And I've explained that the flash memory is a technology of both RAM and ROM. Then the last memory chip, the third memory chip, called CMOS, is a chip that contains programs or contains information meant for upgrade or meant for expandability and flexibility of your computer system. Chips or CMOS chip contain programs that can be used to upgrade your computer system. shapes that can be used to justify compatibility of your computer system with another system or device. So if your computer can be connected to any device, it's the job of the CMOS. If your computer can be upgraded, expanded, it's the job of the CMOS. Moment any device is connected to your computer system, first recognized by CMOS to justify if it is compatible or not. If it's compatible, recognize the type of device, the size, the memory space, and other details of that device. So in computing or in a memory chip, a component that can justify whether your system can work with another device is a job of the CMOS. In the late 90s or in the 90s, computers were not compatible with mobile phones. Why? Because the CMOS was not designed or manufactured to make those systems compatible. But today, the advancement of the CMOS enable you to connect your computer with other devices. You can connect your phone, a lot of devices that can be connected to your computer. And the possibility is done by the CMOS. So it's the CMOS that give you flexibility, expandability, or compatibility of your computer system and other devices. Any device connected to your computer system, details are justified by the CMOS. So for example, if you want to know the RAM size of your computer, is the CMOS that will justify. If you want to know the type of keyboard, mouse, printer you are using, is the type of the CMOS. And this CMOS uses a battery. It uses a battery that keeps track of date and time. So even when your machine is switched off, it's still working because there's a component called battery, CMOS battery, that keeps track of date and time for you. And then the CMOS keep on changing based on the devices connected to your computer system. Good. So concerning the memory, type of processor, microprocessor, memory, types of memory chips, and then the RAM is the popular and types of RAM chips, as well as CMOS ROM. If there's any question, I'll give you about 2 minutes, less than 2 minutes. Where you don't understand, let me explain quickly as we move, make progress. Yes, I'm waiting. Class rep, you are serving in all, eh? What's your total number?
We are supposed to be the our total number is 14.
14.
Yes, sir.
Oh, it's serious. And how many? You are
Uh,
5 today.
so
You are
we
5
have
today.
we are more than 5. So we have
Or more than one person using one device. You are 5 today.
I think we are 11.
Ah. Okay, I'm sorry. Okay.
We have two officials
Okay, I've seen.
and you, sir. So yeah.
Okay.
Yeah, we are by 11.
11. Okay. So I'm waiting for that side if there's any question. Who is
Sir,
Yaila?
sir, please, uh, I want to come in.
Okay. Oh yeah, come. I'm
But before I
waiting.
come in, Mr. Justice just reached out to me right now, and I've complained to him. So he said he'll he'll check right now.
Okay.
Okay, so sir, considering the 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 CPU
Mm-hmm.
that is used in the microcomputers, and then the circuit board. So the circuit board that they use in the bigger system of computer, that's the high what do you call it?
Supercomputer mainframe.
Yeah,
Yes,
the
yes.
supercomputer mainframe.
Mm-hmm.
Does it still have CPU inside it, or only the circuit board?
Uh-huh. The name is called circuit board for that context by the same CPU because every computer has central processing unit that convert data into information.
Hmm.
And the like our laptop PC uses one processor at a time. That's why we
Hmm.
call it microprocessor. But that one consists of more processors, and we call that one circuit board. Circuit board. Are you okay?
Okay,
Your
okay,
phone, your laptop use one processor called microprocessor. But a supercomputer mainframe uses more processors. And then the board that contains the processor called circuit board. So when you hear circuit board means super mainframe or mini component that convert data into information.
okay. So okay. So
Yaira, I'm waiting for you.
Hello.
Is that the lady?
yes, sir. Yeah.
This is my first time hearing you.
Oh, last 2 weeks I spoke.
Okay, let me hear you.
Please, the question again because the network was fluctuating.
I have not asked any question. I said what I've highlighted now. Just about 15 minutes ago. Where you don't understand, let me explain. After I move to the next stage. You've seen the type of
Um,
microprocessor chips. We've seen the memory. Memory chips consist of three. That is a RAM, and CMOS. And RAM also, you see how it works, how memories are measured. RAM types, ROMs, and CMOS. I will explain all this. So I want
yes,
your
please.
input, comment, or whatever before I move to the next stage.
We understand what you thought so far. We understand.
We all have the materials, and I believe you read ahead.
Yes, please.
Okay, so I'm waiting for your comment. Okay, have you seen this? The one I've highlighted.
Yes, please.
Okay. Read for us and tell us you understand it.
Outline the 5 functions of memory storage or the primary storage of the computer. So, what I understand with this question is we are going to explain what the primary storage of the computer is. Then we are going to outline the uses of the memory or the primary storage.
Okay. So I'm waiting for some of the options.
Okay, you've written them below. You've outlined them below. So you're saying that the memory utilization
No,
changes
no, no.
during.
It's a different thing altogether.
Okay. Let me
Okay,
think.
so the question again. Outline the function. Okay, so the primary storage memory, which is the RAM,
Mhm.
it store data as long as there is power.
If you just say that one, I'm not convinced. You should go beyond that. You remember this? I said the memory, that's what store operating system, loaded operating system, and application program temporary. So before you can open Windows or launch Windows, is a memory that holds it for you. Do you remember this?
Yes,
I've
sir.
highlighted this about 10 minutes ago. Do you remember these ones?
Yeah, so sir, I'm writing a point. So that's how I frame it and write it.
Okay, say your point again. Let me hear you.
So it it store data as long as there's a power. And
Okay.
also and also
If you say that one, not
and also
complete too. As long as there's power, data from where?
okay, so sir, it store data from the loaded from
Hard disk.
the hard disk.
Good.
As
Data
long
from
as
the input device or loaded from the hard disk. Are you okay? These are
yeah,
the five
also
functions of memory space.
I say also it assign new storage space for a data or program
Okay, when needed.
when
Are you
needed.
okay here? Good. Now, the lady should continue answering us. Read this and answer. Choose one. Don't tell me the answers are down. Kaila, don't tell me the answers are down. Read and tell me you are
Should I read
A,
what
B,
you are
C, D.
highlighting?
Are you okay with this side?
Yeah, so we are saying that, hello.
I can hear you read.
So you said we should outline the 5 functions of memory, bracket, primary storage. And you're
I
saying that,
can't hear you. I can hear you now.
please, can you hear me?
Yes, now it's better.
Okay, so one of the
Read,
primary,
read the
uh,
question. Read the question.
outline the 5 functions of
Oh, we have finished
memory,
that one.
the memory utilization during
We
processing.
have finished that one. Have you seen where I've highlighted?
Oh, okay, okay. So the system assigns permanent storage space for each program when it is activated.
We can't hear you.
The system assigns permanent storage space for each program.
We could not hear you from beginning. Oh.
The memory utilization changes during processing. This is because A. The system assigns permanent storage space for each program when it is activated. B. All programs use the same size of storage space when activated. C. Each program storage space for execution is assigned automatically. D. Users normally adjust storage space to suit their running program.
Good. So which one is the answer here? Do you understand the question?
Um,
Do you understand the question? We want you to answer everything for us.
yeah, so they are saying that there is a statement. They are saying that the memory utilization.
Yeah. Do you understand the question? Yes, no. Before we make movement.
Yes, I understand.
Okay, now tell us your understanding.
So they are saying that the uses of the memory changes during processing.
Okay, that is good.
That's what they are saying. And they are asking why.
Who is asking the why?
The question is asking why. So
Okay.
the question that provided um A B C D multi choice. So
Okay,
I
so
say that
give us the answer.
so each program storage space for execution is assigned automatically.
Answer A, B, C, D for us. Oh, give us the answer. Is it A, B, C, D? Choose one.
I'm thinking about it. Please, I'm coming.
Okay.
Okay, so each okay, so A. So
The answer is what?
A. The system assigns permanent storage space for each program when it is activated.
I'm not
Because
convinced. I am not convinced. I am not convinced, Yaira.
okay, yeah. Okay, so the reason why I was choosing A is because one of the basic functions of the CPU, okay, or the storage is to store program instructions. So whatever information or whatever storage or anything you put in the computer, for example, Excel, when you input your information on the Excel sheet for it to save, is approaching a particular space. So it's limitless.
We
No
can't
matter
hear you. We can't hear you, and I am not convinced.
using the laptop, so
I said we can't hear you, and I am not convinced.
I was thinking
Hmm.
an example.
Yeah, we can't hear you. I am not convinced.
Yeah. Please, can you hear me?
I can hear you, please. Are you here? Can you hear me? That one can. But when you are talking, we hardly hear you.
I'm using my laptop for the
Okay,
class.
so it should be closer to the laptop, and then
Yes, I'm very close to it, so I'm surprised you can't
now
hear
we can
me.
hear you better.
Wow.
Your question one, your A, I'm not convinced. A means what? Wait, in our system, when there's a problem for women, we say memamro, the buana. Yaira, did you hear me?
Yes,
When,
please. With the support.
again?
No.
Hmm. So don't worry. When there's a problem, the women says memamro. So let me call a man to rescue you. Somewhere, Afari. Somewhere, choose one. Somewhere, Afari. Or you are just connected, you are not here.
Hello, sir. Please, I'm here.
Yes. Choose one. Choose one for us. Which one is the answer?
Um, So the system assigned permanent storage
I said
space.
choose one, A, B, C, D. Choose one.
Oh, okay. The D. The user normally adjust storage.
No, you are not reading well. The B is what? The B? Read the B
So,
again.
all program.
Is your answer B or D? Is your answer B or D?
So this initially I chose D.
And so which one is the final one?
So please, I'll take the B for now.
Okay, read for it.
All programs use the same size of storage space with, and when
You are a computer engineer. You can never use this as an argument. It's not possible. Do you get me? You are an engineer. When you switch on your machine, can you tell a user that whenever you switch on your machine, all programs have the same size?
Okay.
Is it possible? Can you
No,
convince
please.
users that you are using
No,
WhatsApp,
please.
you are using CorelDRAW, they all use the same size?
No, please. It's not possible.
Okay. So which one is the answer?
Programs.
You know why? We
Hello,
only
sir.
say MMAMRO to rescue women. But
Hello,
man,
sir.
when we have problem, nobody is there to rescue. So solve it quickly.
Hello, sir.
Yes.
Please, can I come in?
I said men, when we have problem, we solve it ourselves. But women, we say MMAMRO. But for men, we solve it ourselves. So somewhere should solve it. Be fast.
Okay, so the answer is C.
I said somewhere should solve it.
Oh, sorry.
Okay.
Somewhere I'm waiting. What is the answer?
Okay. Okay. So please, no, each program storage space.
The lady said
So
the
please,
first one wrong. You have chosen B. It's wrong. Remain 2. So which is which?
users. So please, I'll choose that of the.
The thing is A, B, C, D.
So,
So choose one quickly.
so please, I'll choose the that of the D.
D. Read for it.
The users normally adjust storage space to suit their running program.
Samuel, you are scientists in the field of computing. If you switch on your phone, can you assign space to WhatsApp? Can you assign space to normal text? Yes, no.
Then no.
So you are scientists in the field. So act like scientists in the field. Do you understand?
Yes, sir.
Now you have chosen 4. And you have chosen 3 out of 4. So the last one is what?
So each
I could not get
for
you well.
execution. So please, the C.
Say it again.
Okay. So each program storage space for execution is assigned automatically.
Yes, we have highlighted it there somewhere.
Yeah.
That when
Yes.
you switch on, it does it automatic. You cannot assign space to your machine that use this space for this program, this space for that program. It does it automatic. Do you agree now? Do we all agree it's C?
Yes, sir.
So memory utilization is automatic. Put in mind that you see some of this in your objective questions. Good. I'm here now. Another person. Is Ralph here? Ralph.
Hello, sir, I'm here.
Yes, we are waiting for you.
Okay, sir.
Read the highlighted for us.
The type of bus in a system unit that supports the processor for the write cycle, but driven by the memory for the read cycle is called.
Good. So let me show you that side and read quickly. Where we have the bus.
So I think
It's under the memory.
Here. Okay. So tell us the answer quickly. Have you read yet?
Come again, sir.
Have you read this side again?
I can read it, sir.
Okay.
So, address bus.
No. Read to your hearing. Your own.
Oh, okay.
Just 10 seconds, then we go to the next side.
Okay, sir, I'm done.
So tell us the answer.
Sir, A.
A is what?
Data bus.
Do you agree?
Yes, sir.
yes, I said it long ago before.
Don't say I agree.
I was writing the point, so when you asked the question on me, I see. Hello?
Engineer,
I feel like the lecturer in line go up.
that what I check self. So you check like the host they still there on the host they record.
I beg call the election. Call the
The
election.
election they come out for the this thing top we free to crowd.
I beg, make you give am Starlink.
Okay, so say he's aware of the issue. So he said he's joining back.
Okay, so here we have understood the answer here. So you agree the answer is what?
Data bus.
Okay. And here has two ways. The processor writes and then the memory reads. Okay. So you go to, these things are not new to you. What is storage drive? The storage drive are the letters you use to assign storage device. Like drive C, drive A, you are aware of that. How to format a disk. When you purchase or get a new disk, you only first thing is to format it. And the formatting here means to initialize it so that the system can understand it and work with. You have done computer definitions this side, good. We have something called symbolic language, which is the zeros, these ones, and then the machine language. We've done the definition of computing. or computer from the beginning. So you're okay with this. Those days, or this is the language of the computer, zeros and ones, 8 zeros and ones represent this. So using computer those days was very tedious and used by computer scientists, because before you can type this, you need to know combination of zeros and ones. This side going out straightforward. When you read the keyboard, the last time we did the keyboard, so all this side, okay, go straight to this system unit. We are here now, system unit. A computer is a system, consists of different units connected together. The main unit, which also sometimes called CPU, the keyboard, the mouse, the screen, and then the main case, we sometimes call it CPU, central processing unit. When you open it, there's another key component called central processing unit. Computer consists of units. That's why some people call that one central processing unit, CPU. But the main name is called system unit. The system unit is the main case hardware component that consists of different internal components, or that houses the internal component and then the software. So all your software, internal components are housed inside the system unit. We also call it system cabinet, or for the mainframe, system board for microcomputer system. So okay, it's sometimes called system cabinet in a supercomputer mainframe. And then in our microsystem, we can also call it system board, the system unit, the main unit, or system board. Then when you open this system unit, this is how it is. This is a system unit, how it is. The big case, where all the components are housed. Your software inside this, your memory inside this, your hard disk inside this, your processor or microprocessor, they are all inside the system unit. These are the components associated with system unit. There's something called power supply. And this is the power supply here. Power supply, this is the power supply. Every PC or every computer has a power supply. This power supply provides electrical power to all the components in the computer system. We don't connect mouse to a computer power. We don't connect keyboard to a power switch. They all get their power from the power supply. So power supply provide electricity or electrical power to all the components inside the system unit. This means when you switch on your machine, you are aware from the main switch, everything is on. But there's nothing showing, no light, no signal showing on the screen. Then put in mind that there's problem with the power supply. This power supply can be replaced if it's not functioning. So if there's nothing showing, no light showing, but your power is on, then put in mind that the power supply is not functioning. It's this power supply that makes the computer system free from electrical shock. You are aware that it uses electricity, and when you touch the electricity, you can get shocked. But this power supply converts the alternative current that is AC to the direct current, so that you can use it without shocking or any problem. When the power goes off, your system will not work. When there's doom, so the system will not work. So the best option is always there's a standby power core or power system storage core, UPS, uninterrupted power supply. So if your machine, your main, or let's say there's a DOOMSOL, ECG DOOMSOL, you can use what is called UPS to provide power for you to work with your system. Another component called main board. And this is the main board, the motherboard, from here to the end here, from here to the end, where all the other components are seated. So you can see all these components are seated on the main board. At the back of the main board is where we have the bus. The bus are there. The bus that shows the lane. So here you can see the RAM chip, the processor, they are all on top of the motherboard. The motherboard main board communication network for entire computer system. So the main component in the system unit that houses other components or other components are stored called motherboard. Every component of the computer system is connected directly to the motherboard. So your keyboard directed, your mouse, every component in computing is directly connected to the motherboard. And at the back of the motherboard is where we have the bus. So signal movement, control all pass through the bus. If it functions as a data bus that enables various components to talk to each other. External devices like this are also connected with the motherboard that support them to work. And this is a picture of the main board, the system unit, how it is. This is your hard disk storage are here. This is our core port where external devices can be connected. So this is how the system unit is. Another component associated. Here is called RAM chip. They are all here. Other components that are associated with the motherboard or main units are here. Good. Then there's something called strut or expansion board. At the back of the PC called expansion board or strut, where external device like modem, sound card, the monitor, the TV card can be connected. Here called strut or expansion board. You can expand here if you don't have network interface. You can expand here and have a network. If you want TV to be connected to your computer, you have to add additional device. And this is called expansion board or slot area where other devices can be connected. So when you hear expansion in computing means upgrading. You are adding new device to your computer system. If you want to connect your phone, you need the USB port. If you want TV to be connected to your computer, you need TV card. If you want to use your computer for networking, you need network card. So expansion board or slot support extra or additional component to be added to your computer. And when additional components are added, we classify them or classify it as upgrading. You have upgraded your computer system. And here are some of the board or card that can be added to your computer system. We have something called network adapter card. You connect that one at somewhere here, network card, so that I can connect a cable to it to have access to network or internet. The network card connect computer to others. Support it to connect computers to others through cable. And this card is normally used to share, or this card supports you to connect so that your computer forms part of the network to share resources. Then the next is, these are the functions of board or cards. The cards is the same as board. That can be added. So these are some of the cards or boards that can be added to your computer system to upgrade. There's something called small computer system interface. Most computers have limited expansion slot. You can have this one card that can connect several devices to your computer system. There's TV card that can also be added, PC card, memory card, adapter card, control card, oscillator, emulator, modem, fax, sound, voice. These are different cards, components that can be added to expand your computer system. So if you buy a computer, settings are not there. You can add them so that you upgrade your computer to meet your needs. Different expansion cards or boards that can be added to your computer. Control, oscillator, emulator, fax, modem, graphics, sound. For example, the voice card supports voice output. No voice card, you cannot hear. Then the sound card, when you speak like microphone or whatever, convert this sound into output for you. The next one is port. And this here are called port. The port, the same as the card, that enable external devices to be connected to your computer system. What is port here? It's a bridge, a connection that supports external devices to be connected. Before you can connect the monitor, must go through port. Before you can connect the printer, must go through port. So port enable external devices to be added. And these external devices enable software and other things to be installed into your computer system to update good. And these are the different ports. Ports are available in your computer system. There are a lot of ports. And here, even without much technical knowledge, you can connect your device by having the correct port accordingly. It's impossible to connect maybe mouse to this. It's impossible to connect maybe a keyboard to this. These are old type of keyboard, old type of mouse. Different port. Every device has its own port, so it's impossible to connect a device to a different port. Each port is also compatible with its specific device. Different ports are available in PCs where your device, external device, can be connected. The ports are grouped accordingly. Various ports. We have power port, serial, isolated, USB, electrical, and HDMI. The power here used to connect external devices, and this power consists of 8 pins. 8 pins normally for short distance. So the power ports like this. These 8 pins. 8 pins each deal with 1 byte at a time. So here, which send or receive data in a big amount for short distance. This normally send 8 bits at a time. Normally for printer connection. More powerful, send more data. And the serial short distance, this one sends 1 bit at a time. The bit is the smallest unit in an information system as a signal movement from one place to another. And the serial normally for long distance, 1 bit at a time. This connects the monitors, projectors. So AGP or accelerated graphic port meant for connecting monitor, projector to your computer system. Then the USB, you are aware of how it works. The USB have different types. Type C is more powerful. That can translate or transfer 40 gigabytes per second of data. And this one replacing the USB port, replacing the serial and even the power. Then electrical wire also more powerful than the USB. HDMI, as see also latest, very powerful that transfer huge amount of data from one place to another. And also support the projector, monitor, TV, cameras, and other devices. HDMI, we have different types. The latest is 2.1. And that one, movement is 84 gigabytes per second. So you can translate or transfer large volume of data or signal from one place to another. The USB support 40 and this 84 gigabytes per second. So you can transfer large volume of data at a time. Good. This also another part of the CPU, the system clock, the bus lane. You have mentioned the system, the bus, how it works. And the CPU is measured in hertz, whereby the memory, the processor, the memory, and then the hard disk measured in bytes. The system clock here is a circuit chip which generates electronic power at a fixed rate to synchronize the timing. Good. There's a clock assigned to your computer system. That's why when you off, you switch on, you show you the time and etc. We have experienced or have explained the bus. This is how the bus looks like. And then the bus here, we have three types of this bus architecture. One is called ISA, PCI, and AGP. The industrial standard architecture called ISA bus, built for IBM. The old type of computers still use IBM, Novera, or whatever. Have been transformed to different parts. And this capacity is 8 bits and 16 at a time. Most today's machines are not using this technology, more powerful than 8 bits or 16. Despite being not fast enough, it's still being used. This 8-bit 16, as most computers today don't use this, but still in use. Some also use this one, 8-bit, 16-bit at a time. The bit is a smaller unit, more bits, more signal. Data can be moved at a time. Then the next is peripheral component interconnect. It's an advanced form of ISA, and here support 32 and 64 bits. And here support video or multimedia programs. So this type of bus support multimedia where large volume of signal can move from one place to another. There are some programs, if your processor's strength, the PCI is not 64, you cannot install on your computer. Some support 32-bit, some 64, more advanced. So when you are buying a computer, not just the processor, you also need to consider the type of PCI. Is it 64, which is faster than the ISA, or 32? The 64 is more faster, which is about 20 times faster than the ISA. Then the next one, AGP, more advanced, support 3D, multimedia, more powerful graphic editing. And this is more powerful than PCI. So these are the three types of the bus link: ISA, PCI, AGI. Good. The next is input. The last time we did something about the input. We learned about the keyboard input support is the same signal, then the output. So this input, output, we are not going to waste time here. Simple for you. We highlighted on the keyboard and then the mouse. Input device that support to send signal. So these are the various input devices. And then the input types, we have 3 approaches. Input method, 3 approaches that support you to send data into your computer system or database. 3 approaches that support you to send signal or data into your data system. So making entry in the computer system, we have 3 ways. One is offline, online, and interactive. Let's start from the interactive here. Interactive here means the 2 parties must be there simultaneously before interaction can take place. So you send something, the person responds, you send something, the person responds. And that is called interactive, like how WhatsApp, you send, the person responds, you send. There are some systems where the 2 parties must be there simultaneously, like what we are doing now. The online for teaching, the Zoom interactive, where I send message, you can also respond in that thing. This is called interactive data entry. Interactive data entry means the two parts means the system must be connected. And this interactive here means anytime input is made, the system will verify whether it's there before you can access. Remember, there are some forms, online forms, when you are filling, you type maybe your name, your ID. Moment your ID is typed, it verify, check whether that one is the genuine one before you can move to the next stage. Example, when you are entering password into a system, it's also part of data entry. You enter password, you go and check whether your username is correct, your password is correct, and that is part of interactive. Each entry is verified from the database before you can move to the next stage. So this type of entry, for example, you have entered your name, ID, date of birth, and the power goes off. The next time when you reconnect, you not type your name, date of birth again, because that one has been verified. You move to the next stage, and this is called interactive data entry. The two parties must be there before interaction, and each field must be verified before you can move to the next stage. If your date of birth is not verified, you can't move to the next stage, and this is called interactive data entry. The next is offline. Offline means not necessarily your system has be connected. You can do the entries, everything you want. Then once finished, you upload to the system database. Another name for the offline is called batch processing. For example, if the university want to store all students' profile, doesn't mean that one by one. Can offline then put all your profile at one side, capture all, could be Excel or any other means. Then once the system is connected, send it all, and this is called offline data entry. And this type of entry give you chance to verify before final submission. You go through to check for mistake, make correction before final submission. And then the last type of data entry is online. Here means the two parties, the internet must be on. And data is entered directly and examined as examined. So the online here means the system must be connected. And here you can finish like a form, you can finish all entries of your form. Then once you finish, you choose send or submit, and that is called online. And once you say send or submit, your input will go directly to the database. So these are the three approaches that can support you to enter data into a database. Then the next one, also two types of input devices. To make entries into the database, there are two types of input devices. One called direct and another indirect. The indirect example is keyboard. When you enter something from the keyboard, the keyboard, once something is entered, it appears in the form of signal, goes into the computer system, then convert into readable before the system will accept. So when we enter something from keyboard, we call it indirect. Data transfer into the computer via the keyboard, and here convert into readable before the system can understand it. And another one is called direct entry. Direct entry means the system has recognized it already. So for example, if you scan your book, that one has been recognized already. So it's not a form of entry via keyboard or indirect. The system knows the context. So here it's not going to convert it to know the byte or space consumed because it has gone through. If you scan your Ghana card, the details are already known, and this calls for a direct entry. Example of a system that uses both direct and indirect entry is point of sales. When you go to supermarket, you want to buy something. They will scan it to bring the item description and unit cost. Then somebody will type the quantity you want. So that quantity entry You want entry, that one is called indirect. And to bring the item details, that one is called direct entry. So point of sale is an example of this combination. Now we have keyboard, mouse. We did this the last time. Good. Input device, pointing device, we did that. And then type of mouse, we have 3 types of mouse. We did all this the last time. So here, type of mouse, 4 type, the wireless, touch sensitive, optical, then the ball mouse. The optical mouse is the one with the light. Then this is the old type of mouse with the ball inside. Then on your keyboard, you touch a mouse to roll, and that is touch sensitive, and there's wireless. So these are the type of input devices. Good. I'll start the next meeting. We start from here. Input method. All this side or input control. All this side are straightforward when you read. Those have jump here. They are known to you, your day in, day out activities. They are known to you. So this side are straightforward. You read before you come next meeting for anything. Good. So that's that for the day. If there's any question, I'm ready for you for the day. I'm waiting for your questions.
Okay, sir.
Yes.
Sir, so please, my question is a system unit have a
Yes.
input Wi-Fi card.
System
So
unit what?
have input Wi-Fi card.
The
So why
Wi-Fi card.
so what so in which situation do we need the external adapter, which is the one we slot
That's
in
the
the
card.
in the expansion board?
When you need that device, when you need that application, when you need that technology, like you may mention Wi-Fi, the wireless fidelity here, you want to connect that card. You want to
Okay.
connect that component.
Okay, so for that
Then
one,
you,
that
then
one
you
is for
need,
Wi-Fi.
again,
That one is for Wi-Fi only, the external one.
external one. I'm not
The
getting your question.
the external network card. Is it only Wi-Fi?
No, any card you want. For example, if you don't have the RJ45 connector, do you know the connector, the cable?
Yeah, the RJ45.
Aha. If you don't have network card, then you can buy the card so that you can access the RJ45 approach.
Okay.
So if the card is not there and you want, you use that one, you add it to upgrade your computer system.
Oh, okay. Okay.
As in I'll post the assignment today and might be submitted before our next meeting. I hope it is time now.
Sir, so the assignment we will submit it on the LMS or?
Yes. Can you do that? We should make use of that. Okay.
You will do that so that when we can upload it for you on the LMS, everybody can upload for you, then you can see it at your
So
end.
I'll put in the assignment column and see how this one will work.
Okay, okay.
If unable, then we
Then
use
I'll
the EPA.
Then I will contact if there's a challenge, I will contact Mr. Justice again.
Okay. And as if unable to, then we use the email system.
Okay.
So I'll post the assignment. Good
Okay.
afternoon. Good morning, right? I'll go over the next meeting. Bye.
So thank you very much for today.
Bye.
At 11:30. 11:30. So it's almost time. It's about 27 minutes. 23 minutes left.
Good morning, everyone.
Good morning, sir.
Yeah, let's start to go ahead and do our studies this morning. All right. Next week, God willing, we'll meet on Friday because this last Friday was a holiday, which is what yesterday. So I didn't want to disturb your holiday because we have some Muslims among us, so they had to really do their thing. All right.
Yes, sir.
Yeah, so that's why I didn't worry myself for it yesterday. But this morning, the last time we were doing ionic bonding. All right. So today we'll continue off from the bonding that we ended the last time. So we'll tackle the covalent bond, right? Some atoms, some of them, right, they don't give or gain electrons easily the way some atoms are. So, but they always also participate in compound formation. So how they do it, right, is what we are going to learn. Those who don't give away their electrons and those who don't collect electrons, how do they do it? All right. What they do is they share the electrons so that they can satisfy the octet rule. About the octet rule is the ability of the design of the atoms to get 8 electrons in their atomic shell to satisfy that. So that's what they do. Instead of giving away their electrons or receiving electrons, they themselves, what they do, they share. They share electrons. That's what we call the covalent bond. All right. Called the covalent bond. Taking for example, hydrogen. Hydrogen atom has only 1 electron on its atomic shell. Right. That shows the 1s subshell. So for them, right, they start with just one, right, one electron. But then they want to satisfy for hydrogen is different. That is not really an octet like 8 that we are talking about, but oxygen to become stable, to achieve its stability, then we have to have two electrons on its atomic shell. So the hydrogen has to find another hydrogen, bonding with it in the presence of another hydrogen, bond with it, and then share the electrons. All right. So then each hydrogen will have 2 electrons at their atomic shell, how you can see from here. Right. This hydrogen now come together with this hydrogen, then they have 2. So everybody will have 2, right? So that's why we call the covalent bonding. So because each hydrogen atom has a filled valence shell, this bond is stable. Once they have the filled valence shell, then the bond is stable. The atom becomes stable. So that one becomes a diatomic molecule of hydrogen. That's why we say hydrogen is a diatomic molecule. All right. So we can also represent this bonding, right, with a structure like this, H-H, right, A-H. So this one is just only a single bond. It's a single bond because it's just 2 electrons that 2 atoms are sharing, right? So we call it a single bond. We have double bond, we have triple bond, all right? So this one is a single bond because it's 2 electrons. Now let's talk about fluorine. Fluorine, it has how many? 1, 2, 3, 4, 5, 6, 7. It has 7 valence shell electrons. All right. So the fluorine, because it has 7, right? You want to satisfy the octet rule. So you want to have 8 electrons on this atomic shell. So then it looks for another fluorine and then bonds with it. All right. So that 1 electron that is left to make it 2, to make it 8 electrons at the valence shell. So then the other fluorine also will bring 1 more. So then they will share together, like how you see here on the screen. All right, this fluorine and that fluorine, they will come together like this, and now they will share common electrons. They will share common electrons. That 1 here, 1 here, they share, so they become 2. All right, so if you count on this fluorine has 8, and this one too, it has 8. All right. So bonding electron pair makes the covalent bond. All right. If fluorine atom has 3 other pairs of electrons that do not participate in the bond, all right, they are called lone electron pairs. So the lone electron pairs, the ones that don't take part in the bonding, we call them lone electron pairs. All right. And the one that bonds, has the bonding, we call them a bonding pair. All right. So it has fluorine has 1 bonding pair and 3 lone pairs electrons. Okay. Because it's 3, 2, 2, 2, 6. Right. And this one too is just only 1 pair. 2. So covalent to the one that we showed before, right? It was a covalent bond between just only same element, right? Say atoms. But this case, right, the covalent can also happen among between different atoms. All right, different atoms. So now let's see hydrogen and fluorine. Right? Hydrogen has only 1 electron. It wants to satisfy itself to become 2. Hydrogen is different, right? Fluorine too has 7. It wants to get 8. So then the hydrogen will come and bond with the fluorine here, and then they will bond together like this. Now hydrogen has 8. Fluorine too has hydrogen has 2, fluorine has 8 electrons. Right? Let's go back. Example, use Lewis electron dot diagram to illustrate the covalent bond formation in hydrogen bromide or hydrobromic acid. Right? So now we have hydrogen and bromine, right? Hydrogen and bromine. So hydrogen has 1 electron, bromine has 7 electrons. All right. Bromine wants to achieve the octet, so it needs 1 more. And hydrogen wants to also have these 2 electrons on this atomic shell. So how do we do? The bromine comes, hydrogen comes, they bond together. Then this one, the last half pair of here of the bromine bonds with the 1 of the lone pair here, right? And then you get hydrogen has 2 electrons and bromine has 8 electrons. Is there any question? All right, let's keep on going. So use Lewis electron dot diagram to illustrate the covalent bond formation in chlorine. I want you to try your hands on this. All right. Before we move on, let me see if you understand what we are doing. And then let me give you about 2 minutes, 3 minutes. All right. It's now 11:40, 11:43. I'll start talking again. Yeah, I think if you understand it, you should be able to finish it now. So you are welcome back. All right. So let's see how we do it. All right. Let's see how we do it. This is how they bond. And you see this dash there, right? This dash here. It tells you that it's a 2 electrons. When there's dash, 1 dash like this, there's 2 electrons. When there's 2 dashes, that means 4 electrons. When it's 3 dashes, that means it's 6 electrons. Every dash represents 2 electrons. All right. Every dash represents 2 electrons. Now, so now let's see. More than 2 atoms can also participate in covalent bonding, although any given covalent bond would be between 2 atoms only. Hydrogen and oxygen atoms forming covalent bond. Hydrogen, we all know it has only 1 electron. Oxygen, how many of them? It has 6 electrons. It is atomic shell. So then if 1 hydrogen is there and it bonds with an oxygen atom, oxygen will have 7. hydrogen will satisfy its octet, right? Hydrogen's octet is just 2. So then what do? There should be another hydrogen also that will come and help the other hydrogen and bond with the oxygen. Then hydrogen will be 2 and the oxygen will be 1. All right. Then oxygen will be 1. So that's why we have H2O. All right. Water, if you want to form water, say H2O. The 2 didn't come just like that. It came from this bond, right? 2 hydrogen didn't come like that because 1 hydrogen doesn't satisfy, made the oxygen satisfy its octet rule. So we need 1 more hydrogen that has 1 electron to also share with the oxygen. So then we have 2 H2O. You see. Let's see the ammonia also. Use a Lewis dot diagram to show the covalent bonding in ammonia. Right? The N atom has following electron dot diagram. Right? So we put it there, the first 2, right, for the S orbital and S yeah. And then the rest of them you share them. So you see, you have 1, 2, 3, right? It needs 3 more hydrogen to bond with it. You understand? So that it can satisfy the octet rule, the nitrogen will satisfy the octet rule, and then the hydrogen will also satisfy itself, right? So that's how ammonia is formed. All right. Use the electron dot diagram to illustrate, to show covalent bonding of potassium trichloride, right? You see, potassium, phosphorus dichloride. Sorry. So the phosphorus is there. You see that it needs how many? 3 electrons. Needs 3 more electrons. All right. So then it has to get chlorine, 3 of them. And then they will come and bond with the phosphorus, right? Come and bond with the phosphorus in the middle. And then it can satisfy its octet. All right. So there are steps that you need to follow to do the bonding, all right? To do the bonding to satisfy the octet. So the central atom is usually written in the formula of the compound, all right? The central atom, right? What you do is this: you count the total number of valence electrons, all right? Then you add extra if the species has negative charges, and remove some for every positive charge on the species, all right? Then you write the central atom and surround it with the surrounding atoms. You put a pair of electrons between the central atom and each surrounding atom. Complete the octet rule around the surrounding atom, except for hydrogen. Put remaining electrons, if any, around the central atom. Check that every atom has a full valence share. All right. So it's only hydrogen, except for hydrogen, that it has to satisfy this octet. All right. Another example says write the electron dot diagram for this hydrogen and bromine and fluorine ion. All right. So here you see it's negative ion, right? It's anion. So what has happened? That species has gained an electron, right? So whenever we count it, we have the number of electrons that will get as its valence. We need to add 1 to it. All right. So the boron has is the central atom, and the fluorine atoms are the surrounding atoms. And there's an extra electron. So one, count the total number of electrons, right? So boron has let's see, 3. Boron has 3 each, right? Each fluorine has 7. right? And there's an extra electron, so it's 3, 7, 7, 7, and they have one more, so then it becomes 32, right? So they write the central atom surrounded by the other atom, right? So write the boron, and now once you've written the boron, then you surround them with the fluorine, and then start put 1, 1, 1, 1, 1, right? And then you go around again and you put 1, 1, 1, 1. You see that you will get the octet rule, right? So that's how this is done, right? If there's any extra electron, then you can put it in at the central atom, all right? Now, what we did is complete the octet around the surrounding atoms, except for hydrogen. So this uses up 24 electrons. So it's 24 minus 24 give us 0. So we have none left. If we were some of them left, we could have put them at the central atom. And that's it. You're done. There was no any remaining atom. It says, listen, put the remaining electrons, if any, around the central atom. There are no additional electrons to add to the central atom. Check. The boron atom has 8 electrons around it. And so each chlorine atom also has 8. So then everybody will satisfy that, this octet rule, right? There are some point that we have to find double bond, right? Right. So that one needs to recognize. It comes with practice. It comes with experience, right? Recognition that two atoms can share more than one pair of electron. One pair of electrons. Some of them can share one pair of electron. All right. In each case of CH2O, the O and C atoms share 2 pair of electrons, with the remaining Lewis electron dot diagram as a result. You take a look at it carefully. Right? We have oxygen, and then we have carbon, and we have hydrogen. All right. If you count them, you see that if you are not careful, you see that okay, if I count all the carbon, the atoms, and I count the hydrogen, and I count the oxygen, all these valence, if you proceed them, it will not be proper. So then you have to recognize that, okay, the hydrogen will just can satisfy only 2. All right. So if I put one hydrogen on the carbon and I put another hydrogen on the carbon, there are 4. What about the rest of the 4 that I need for carbon? All right. Oxygen too can satisfy, has 8 valence electrons. So what do I do? Then you just use your wisdom and then your intuition and your also experience to say that okay, let me add 2. So if carbon has 4 electrons and oxygen also has 4, then the octet will be certified. All right, so that's what is going on, right? Like here. All right, so that's how this one, the double bond and triple bond is not straightforward. Then when you get it now, then you have to think a bit extra. You say that okay, if I do it this way, what will happen? If I do it this way, what will happen? So then let me do it this way. Then you get a triple bond or double bond. But then by so doing all the time, then you get experience. Oh, okay. So when you meet, next time when you meet a situation like that, then you know, oh, you're in good business. All right. So that's how this one is. Unlike the single bond is so obvious. But for the double bond and triple bond, you have to think a little bit extra. Now, what is the Lewis dot electron dot diagram for carbon dioxide, right? CO2, right? Solution. The central atom is a carbon atom with oxygen atoms as surrounding atoms, right? So the center will be carbon and the oxygen will be surrounding it. Right? Total number of valence electrons are 4, 6, and 6, which will give you 16, right? So make a double bond between the carbon and oxygen atom. Right? So if you don't do it that way, you won't satisfy the octet rule. Like I said, this one is not obviously that, when you get it. So how are we going to satisfy them? Why you have 16 electrons, carbon has to get, its valence is 4. For oxygen, it has how many? 6, 6. So if you put the 4 here, right? If you put 2 here and 2 here, and then you put oxygen, you put 2 and 2. Then the rest of them, you just have to bond it with, carbon and oxygen. All right, put 2 here, another 2 here. So that will be double bond for carbon and oxygen, and then there will be another also single bond for carbon and oxygen. All right, so you take a look at it. All right. Now, if you didn't know, now you know. So if you have carbon and you have oxygen and you are bonding the carbon dioxide, all right, you have to have a double bond inside. All right, that's how it is. So it is also possible to have a triple bond in which there are 3 pairs of electrons between 2 atoms. For example, nitrogen and acetylene, right? C2H6, H2, right? N2, right? So this one, for the nitrogen, look at it. 1, 2, 3, 4, 5, 6. All right. So how are you going to satisfy the octet? Definitely, there has to be triple bond somewhere now between the nitrogen. So if you have 3, you put a 3 inside, right? That will bond the 3. Then you put 2 and 2 outside. Then you are done. All right. So that's how it goes. And then for the acetylene too, carbon is carbon and hydrogen. So how do you know hydrogen? It has to pair with it has to have only a pair of electrons, hydrogen. So then what do? Then the the 2 of the carbon has to have 3 pairs, right? 3 pair of electrons before the carbon. Right? 3 pair of electrons before the carbon. So polyatomic ions are bonded together with covalent bonds because they are ions. However, they participate in ionic bonding with other ions. So both major types of bonding can occur at the same time. So the equal sharing of electrons in the covalent bond is called a non-polar covalent bond. Right? The equal sharing. Right. So some of the bonds that when the electrons, when they are shared, right, they share equally. All right. You see what I'm talking about in a short while. When they are sharing the electrons, they share equally. At some point in time, that some of the electrons will pull more. Some of the atoms will pull more of the electron to themselves. Leaving the other one to help. It's like animals when they get food, right? Animals when you watch the TV, the strong ones, the ones that are strong, they take the more of the food and leave the weaker ones, small of the food. Same thing with this one. All right. For the atoms, the one that is stronger, it push more electron to itself, even though they are sharing. But then the other one, the stronger one, will pull more of the electron to themselves, right, than the other one. That's when we say that we have non-polar covalent bond. When it's polar, that means they are all one is pulling more. No, none one, one is pulling more themselves. Right. So this is the equal sharing. The equal sharing is non-polar. the one that pulls more is polar, right? Let's keep it this way. The one pull more to himself is polar. The one that shares equally is non-polar. All right. Because we have positive end and we have negative end. All right. Like I say in a short while, we see. For example, we have hydrogen atoms, right? Hydrogen atoms, they all have an equal strength. Two hydrogen atoms. So it will be non-polar because this hydrogen atom, the hydrogen, they have the equal strength. Right? So they will share equal. All right. So covalent bond between different atoms can attract the shared electrons by different amounts and cause an imbalance of electron distribution, which is the polar that I was talking about. Let's see hydrogen and fluorine. You have two different atoms involved in this bond. The hydrogen atom is not that strong, to pull more, to attract more electrons. So, the fluorine, right? The fluorine will attract more of the electrons. All right. So that becomes a polar. So the hydrogen atom attracts electron less stronger than fluorine because the number of electrons, because the number of protons they have, right? So it becomes polar. So when we represent them, right, in a bond diagram and in a structural way, this is how we see it, right? See that is polar, the hydrogen and then the fluorine. You see where the tab is, where that tab is bigger is where it pulls more. See the tab, right? Look at this tab where the cursor is. This side here, you see there's a flat, that one is flat and it's bigger. So it tells you that the fluorine is picking big, it's attracting the electrons more to itself. And the hydrogen, the tip is small, right? The electrons in the bond being nearer to the fluorine atom than the hydrogen atoms. Yes, now this. All right. The electrons in the bond being nearer to the fluorine atoms than the hydrogen atom because the electrons in the bond are nearer to the fluorine atoms. All right. This side of the molecule takes on the partial negative charge, which is represented by partial negative, that sign. Yeah, there and the minus. The other side of the molecule, the hydrogen atom, adopts a partial positive charge. This is represented by del plus. So this is del plus and del minus. Or you can write it this way. So any covalent bond between two different elements is polar. Right? Technically. But a covalent bond between two different elements may be so slightly imbalanced that the bond is essentially non-polar. Right? So a bond may be so polar that an electron actually transfers from one atom to another atom, forming a true ionic bond. So a scale for judging how much atoms of any element attract electrons is called electronegativity. So electronegativity is a unitless number. The higher the number, the more an atom attracts electron. Right? So we use electronegativity to make predictions to see whether this atom will attract more electron to itself than that. All right. Let's see, we have a table like this or a chart. Let me enlarge here small. Philip, Philip, you can talk. I see that your hand is on.
Okay, sir. Thank you. I said so. As the octet rule says that atoms are most stable when they have 8 electrons in their outermost shell. That's the balancing shell. Uh, does it mean that if like let's take two atoms, if they both have uh 8 electrons on their outermost shell, does it mean that they cannot bond?
It doesn't mean that they cannot, but if they don't have, that means they even want to bond. If they don't have 8 electrons, that means they even have to want to bond. If they don't have 8 electrons, right, that means they
Mm.
want to bond. That's the reason why you see the noble gases, they are inert, because they have their 8 electrons. If you already have 8 electrons, then they are mostly, inert. They don't want to bond because they are stable. But if they don't have, that means they want to bond. It doesn't mean that they can't bond. Is that your question, right? That doesn't mean that if they don't have an octet, that doesn't mean that they don't want to bond.
Let's say we have two elements that are stable. They have eight valences on electrons on their valence shell, which means they are stable. Those stable elements or these stable atoms can they bond together?
Yeah, but what
The-
do you think? What is your view on that? What is
so
your
me
personal view on
okay, so I was thinking because they both have stable electron that no one is able to no one is willing to donate. Then it means they can bond since it's only the valence electron that creates the bond.
Yeah, that's the reason why it's not every um element that can form a reaction with another element. Do you get it? It's not
Okay.
every element can have reaction. There are some elements you put them together, nothing will happen. Do you get it? Because they cannot really bond.
Okay.
So it's not every element you put this together now because it's chemistry, then they bond. No, no. They have to have some kind of,
Okay,
kind
sir.
of maybe they are lacking they are lacking electrons and they want to be stable. So then the other one is maybe have more electrons. You want to satisfy the octet rule. So rather he will donate his electrons to other atom, or they will also, attract another atom, or they will share. Do you get it? That's the reason why some of the elements they are inert. When we say inert, that means they are weak. They don't want to bond because they are always stable. They are okay. They get it.
Okay, sir. Sir, can we take a typical example as oil and water?
Um, Unless you do the analysis, you do you take the type of the oil and you see, but this is the thing, in chemistry, right? In chemistry, we have something we call like dissolves like, all right?
Okay.
We are not doing organic chemistry, so, but we have like, we say like dissolves like, water and oil. Water, oil is organic compound, you get it? And then water is inorganic. So because organic and inorganic, when you put them together, they become immiscible. So the water cannot really dissolve into oil because this is organic and this is inorganic.
Oh, okay.
Yeah. So you see, chemistry there's more to it than how you see it. You can't take oil and put it in uh, take water and put in oil and then expect them to, because they are unlike chemical. This is organic, this is inorganic. So they cannot really um, mix. But that's different. But the fact is this: if you have some atoms, when you put them with another atom, nothing will happen. then nothing will happen because they cannot really. This one has certified is octet true. This one too has certified is octet true. So there's nothing that they can do. They will just be there. But this one, has not certified is octet true. This also has not certified octet true. Then when you put them together, then they will bond so that they can satisfy its octet true. Do you get it?
Yes, sir. Yes, sir.
Good. This is the electronegativity chart. Form that you can take a look at it. Let's see. So for here, you see hydrogen, you have lithium, sodium, and so forth and so forth. All right. So those are the electronegativity of the elements. All right. So then putting them together will tell you what you do. We do examples there, and then you see how it is done. All right. So this electronegativity difference, right? If we can say that, okay, this bonding is polar bond, non-polar or polar, slightly polar, or definitely polar or ionic, depending on the electronegativity difference. All right. So you see, if when the electronegativity difference is 0, that means non-polar. You get it. One is from 0 to 0.4 is slightly polar covalent, and from 0.4 to 1.9 is definitely polar. And then when it's greater, electronegativity difference is greater than 1.9, that is likely ionic. You understand? So we'll do example with it. All right. And like I said, this is the chart. You see the chart? Who is talking? Alexander.
Please, is there a way that we can calculate the electronegativity ourselves? In case
yeah, we are going to learn. We are going to learn how to calculate it.
Sorry, can I check my phone? Sure.
Alexander.
Sir.
We are going to learn how to calculate it.
Okay, sir.
But then the numbers there, they are the same. For the numbers, right? For the numbers, they are for each of the elements. For example, if you take hydrogen, it doesn't change. You cannot calculate electronegativity of hydrogen. It is assigned to it. Lithium. Who is that? Please, when you talk, when you finish talking, you have to mute yourself. When you finish talking, you mute yourself so that your background has not disturbed. What I mean is this. See these numbers there, you can see the screen, right? The numbers there, they are the numbers that are assigned to those elements. And you cannot do this calculation like, oh, okay, let me go and calculate hydrogen. Hydrogen is 2.1. So how am I going to calculate hydrogen 2.1? No, that's not how you do the calculation of the electronegativity difference. We subtract the difference of them. That's what you are using to determine whether this is polar covalent, this is ionic, this is slightly, covalent or whatever. You understand? That's the reason why I showed you this chart, right? This table, that electronegativity difference. So electronegativity difference. And this is the bond type. So if the difference, right? When we say difference, it means subtraction. All right. Difference means subtraction. Sum means addition. Product means, the multiplication, the results of multiplication. And then quotient, right, means the results of division. So when this is a difference. So that means you take this element, and you take this element, you take this electronegativity, and you take this electronegativity, and then you subtract, find the difference. And once you get the difference will tell you whether it is non-polar covalent or slightly polar covalent or definitely polar covalent or likely ionic. Do you get it? So we are going to do an example using the electronegativity difference. difference to see the bond type. These are the bond type. So let's go ahead and see. See, this is the polarity of the, see, what is the polarity of each bond? Carbon and hydrogen and oxygen and hydrogen. Then we go to the table and the chart and find the electronegativity of carbon, find the electronegativity of hydrogen, and then we see the difference. Then that will tell us whether it's polar covalent, whether it's slightly, covalent, or whether it's likely ionic or whatever. You understand? Do you understand, Alexander? Do you understand what Alexander, are you there?
Yes, sir. Yeah, I'm here.
You understand what I'm trying to say?
Yes, sir.
Okay, good. So now, let me exit this mode because I don't see anything there. So this is it. All right. For the carbon and hydrogen bond, right? The difference in the electronegativity is as follows. You go and look for the electronegativity of carbon and look for electronegativity of hydrogen. Then you subtract. All right. So when you subtract, you have 0.4, right? And it tells you that this bond will be slightly polar covalent. 0.4. So it will be slightly covalent. See here. 0 to 0.4 is will be slightly polar covalent. You see how it goes. But it falls between here. The electronegativity difference falls between here. All right. So it's slightly polar covalent. All right. Then we do the next one, hydrogen and oxygen. We know hydrogen's own is 2.1 already. Then we go and look for oxygen, which is 3.5. Go to the chart and look for oxygen. Oxygen own is 3.5. Where is oxygen? Oxygen is somewhere, hiding somewhere. You go through. I can't even see oxygen. This is supposed to be oxygen. It's just 3.5. It looks at D, but it's O. It's supposed to be 3.5. So when we say oxygen is 3.5, then you can even go to the net and look for the electronegativity of oxygen. You can Google it. Electronegativity of oxygen. It will come 3.5. So when it comes 3.5, then you subtract the hydrogen's on, which is 2.1. All right. So then when you subtract it, right, you'll get 1.4. When you get 1.4, you go to the table here. 1.4. The 1.4 is from here, 0.4 to 1.9. So 1.4 is here. So it's definitely polar covalent. That's how we do it. All right. That's how I do. Let's do this one. What is the polar covalent? What is the polarity of each one? Right? Rubidium and then rubium and then fluorine. So and then phosphorus and then chlorine. So now they are likely ionic and polar covalent. All what you can do is just go to the table. RB, let's see here, 0.8, right? 0.8. Then you go to the other one too. Which one? Fluorine 0.8. And then fluorine is how much? 4.0, right? 0.8, 4.0. So 4.0 minus 0.8 will give you 3.2, right? So it likely ionic, 3.2. Or if you come here, it's saying that when it's greater than 1.9, it's likely ionic. Right? When the electronegativity difference is greater than 1.9, it's likely ionic. So then this one we have 3.2. So it's likely ionic. Is it okay? Is it okay?
Yes, it's okay.
Yes, sir.
Good. Good. The next one to the is polar covalent. Phosphorus, chlorine. You go to the chart. Phosphorus, P. Where is P? Look for P. So I can't even find it. I can't find it. Or you can go better still, you can go to the net. What is the electronegativity of phosphorus? Use your phone and let's go to Google and find out.
So it is under the nitrogen.
It's under the nitrogen. Yeah. It's 2.1. Thank you. 2.1. And then chlorine. Cl is it's 3.0. So that would be 3.0 minus 2.1, which is 0.9. So then we come to the chart. 0.9 is Fred. So definitely polar covalent, right? So polar covalent. All right. So that's how you do it. All right. But like I said, you can't pick and say oxygen. I'm going to find the electronegativity of oxygen. That one is tabulated, right? That one you cannot say I'm going to calculate the polar electronegativity of that element. But the difference you can calculate it. So the polarity of a covalent bond can have significant influence on the properties of the substance. If the overall molecule is polar, the substance may have a higher melting point and boiling point than expected. Right? If the overall molecule is polar, the substance may have a higher melting point and boiling point than expected. So it may or may not be soluble in various other substances, such as water or hexane. All right, so you see that this thing, Philip asked that question. So it may not be soluble, it may not be dissolved in that whatever. So it's like I said, we'll do solubility. We'll tackle that and you see that it's not all the compounds. When you put them together, something has to come out more. It's not everything that can. Otherwise, we'll have, it's not every, like I said, it's not every element that when you put them together, something has to happen. Some of them, when you put them together, it will be there years, nothing will happen. Nothing will happen naturally, unless maybe maybe fire or something. You hit it to a certain degree or whatever, then something can happen. Otherwise, nothing will happen. You put them together, nothing will happen. For example, if you put your laptop on top of your table, you can, on top of maybe a wooden chair, can be there for years, nothing will happen. Yes, nothing will happen. All right. So if the overall molecule is polar, the substance may have a higher melting point and boiling point than expected. Also, so that means the one that we calculate the polarity or whatever, it's not just like that. We are not just calculating for that, but it tells you things about those elements. Also, it may or may not be soluble in various other substances, such as water or hexane. It also should be obvious that covalent bonds are stable because molecules exist. Covalent bonds, because they are really stable, they are bonded together, and so they are more stable. Right? For most covalent bonds between any two given atoms, a certain amount of energy must be supplied. You have to supply energy. Although the exact amount of energy depends on the molecule, the approximate amount of energy to be supplied is similar if the atoms in the bond are the same. The approximate amount of energy needed to break a bond, covalent bond, is called the bond energy of the covalent bond. So we break bonds and we form bonds. All right. The bonds that we see that this atom and this and that. You look at the microscopic, level, microscopic level. But then when you are bonding, you need some amount of energy so that you can use it to put it together. All right. If you want to break it too, you need some energy to do the breaking. All right. And some of them, when they bond together, they also emit energy. When they come together, like this energy comes out. And when you want to break it, that means you need energy to break it apart. All right. Yeah. And that's why we call that bond energy and covalent bond energy. The approximate amount of energy needed to break a covalent bond is called the bond energy of the covalent bond. All right. So bond, carbon-carbon bond. This is the energy that we need to bond it, all right, or break it. All right. The energy, when you bond it, the energy comes out. So this is how much energy come out. Or when you want to break it, this is how much energy that can use to break it. All right. So the energy is kilojoules per mole. Kilojoules per mole. So 348. And then this is a carbon double bond is 611. Carbon triple bond is 837. Carbon and oxygen 351. And so forth. You can go down, and see all of them. All right. And this one, they are tabulated, right? They are tabulated. But there are some other ways that we use to calculate those bond energy. All right. For bonds that involve the same two elements, a double bond is stronger than a single bond. And a triple bond is stronger than a double bond. All right. It's obvious. It's quite obvious because if you have triple bond, it has to be, it has to be stronger than, because they are bonded, they have 3 chains. If somebody bind you with 3 chains and somebody bind the same, with 1 chain, and the same amount of strength in the 1 chain, so then that three ones, the 3 chains will be stronger than the 1 chain. Right? The energies of multiple bonds are not exact multiples of the single bond. Right? For carbon-carbon bonds, the energy increases somewhat less than double or triple bond. Right? So even though the triple bond may have energy more than single bond, it's not the multiples of it. That's why you have to keep account of it. All right. It does not happen, like, for example, if carbon single bond is maybe 2 kilojoules, so the double bond will be 4 kilojoules. It doesn't happen that way. That's not how it is. The carbon double bond can be maybe 3 kilojoules or 3.5 kilojoules. It's not necessarily like, okay, carbon single bond is 2 kilojoules. So then carbon double bond, 2 times 2, 6. 4, sorry. And then 2 times 3, 6. No, it doesn't happen that way. All right. For carbon-carbon bonds, the energy increases somewhat less than double or triple the carbon-carbon bond energy. For nitrogen-nitrogen bond, the bond energy increases at a rate greater than the multiple of the nitrogen-nitrogen single bond energies. Right. So all in all, it doesn't really happen, like I said before, that if it's 2 kilojoules for carbon bond, then the carbon triple bond, it has to be 6. No. Covalent bond breaking is always an endothermic, right? Right, endothermic process. So what is endothermic process? Who can tell us? Who can tell endothermic process? Nobody. What about exothermic? Endo and exo. Nobody can tell us. Those who have done chemistry before. Hmm?
The exothermic. So normally is how is it is how heat transfer
Endothermic process.
or how heat interchange how element interchange heat.
Yeah. Philip has
So
nobody else can help.
how
Philip.
element heat.
Endothermic and exothermic. Just try to help Philip. Who can help Philip?
So I am talking about exothermic.
You are talking about exothermic.
Yes.
So if exothermic process, right? For example, if I do reaction, right? And it's a exothermic reaction. What will happen to the reaction, the reactants or the product that the product that is inside the vessel?
Wednesday, because you could easily see Robinson coming in today. He's capable. Pierce Jones could have got a start, but he was so happy with the performance.
Alexander.
Alexander, you have to shut down your
situation. What I would say is, yes, he has been.
So what is the exothermic? For example, I put this chemical and that chemical inside a vessel, right? And now the vessel has reacted. What will happen to the process?
The impact he has on the back
the
confidence that he gives.
Alexander, why don't you shut down your the other one, so that you can study here? Because it seems like we are listening to something else. So shut down the other side so that when you are talking here, it won't disrupt whatever you are doing here. Engineer, Philip has done some parts, and we are waiting for other students also to contribute.
Hello, sir.
So for endothermic reaction, right, endothermic process, the vessel or the reaction, it absorbs heat from the surrounding, right? It attracts heat from the surrounding. That's endo. It takes heat from the surrounding to do the process, right? But for the exo, it gives away heat from the surrounding, right? For the endothermic reaction, it absorbs heat from the surrounding, but exothermic, it gives heat off. So when the endothermic reaction, after the completion of the reaction, you see that the vessel will be hot because it has attracted heat from the surrounding. But exothermic, when if you do the exothermic reaction, because the process will give off heat, then it will be cooler than it used to be. When endothermic, it will be hotter than it used to be. That's why we're calculating, delta H, right? Delta H, heat of reaction, right? So delta H for this process is positive, right? Because it has attracted heat. It has gained heat from the surrounding. That's endothermic reaction, endothermic process, right? It has gained. So delta H should be positive. But if the heat of this thing is maybe 2 kilojoules, after the process, it will be maybe 3 kilojoules, it may be 4 kilojoules. It has attracted heat, into the process, right? But for the exo, it gives off heat to the surrounding, so it will be negative because the after heat minus the initial heat, it will be negative. All right, so exo will be negative reaction because it has given off heat. So that's the basic difference between the exothermic reaction or exothermic process and endothermic process. Do you get it? So the delta H for this process for the endothermic is positive. For example, we have molecule, you have a molecule, and then you have oxygen, then you have hydrogen, right? So then you're going to get molecule and then oxygen bonded together, and then you have hydrogen. And then that H will be plus 463 kilojoules per mole. When making a covalent bond, energy is given off. When you are making covalent bond, right? Energy is given off. So covalent bond making is always exothermic. Covalent bond making is always exothermic because energy is given off from the process, right? So in the end, that's delta H for this process is negative. All right. So we have molecule and then the S, right, and sulfur or whatever, and then plus hydrogen, right? And then they'll just bond together because it's covalent bond. They have bonded together. That one, the delta H, right, will be negative 339 kilojoules per mole, kilojoules per mole. Because remember, we are saying that covalent bond making is always exothermic, right? Covalent bond making is always exothermic. Bond energies can be used to estimate the energy change of a chemical reaction. Bond energy change. Bond energies can be used to estimate the energy change of a chemical reaction. When bonds are broken in the reactants, the energy change for this process is indeterminate, right? When bonds are broken in the reactants, the energy change for this process is indeterminate. And when it's endothermic, right, is what? Is positive, right? When bonds are formed in the products, the energy change for this process is what? Is exothermic. So look at it. We have the bond breaking up, right, in the reactant, because you break it before you can bond it, right? When you break the bonds in the reactant, then when you go to the product side, then you form it, right? Then you form it, to give you the product. That one is exothermic, all right? Combining the positive energy change with the negative energy change can be used to estimate the overall energy change of the reaction, right? For example, we have hydrogen and oxygen. You bond them together, right? You can break the bond. For example, here you break the bond, hydrogen bond, you break the oxygen bond before you put them together. All right. So this is how it goes. Bonds broken and then bonds formed in the formation of water. All right. So hydrogen, right? Let's go back there. You have 2 moles of hydrogen and 2 moles of hydrogen, 1 mole of oxygen gives us 2 moles of what? Water. All right. So here, the hydrogen, right? Hydrogen, 2 of them. So you is like this, 2 moles, 1 mole and 1 mole. All right. And then the oxygen too is just 1 mole. All right. So here you need to break it. You break this bond and you break that bond. All right. And now this one too, you need to break it. And then to form this, all right, 2 moles of water. This is 1 mole of water, another mole of water. Let's go back. 2 moles of water, 2 moles of water, 1 mole of oxygen, 2 moles of hydrogen. All right. So now here, 1 mole, 1 mole, 1 mole. So here is 2. So you break it. So what is the bond breaking? Bond energy for hydrogen. So you can use the chart. And there's this, how many bond hydrogen charge. And there's this oxygen double bond. So then you estimate it. And here you do the estimation, right? Do the estimation. Then you can see that, oh, okay, this is how much energy that I used. All right. So now let's see. Hydrogen and hydrogen bonds and oxygen double bond, right? The energy required for breaking the bond is as follows. 2 hydrogen bonds, right? All right. So we have 436 kilojoules per mole. 2 of them, we multiply them. 1 oxygen double bond, we have 498 kilojoules. So then you add them up. So there's the total energy here. All right. So now you have oxygen and hydrogen single bond, right? You have oxygen and hydrogen single bonds. You have oxygen and hydrogen, energy given off when the 4 oxygen and hydrogen bonds are made, right? So now you have oxygen and hydrogen bond, right? Oxygen and hydrogen bonds. I'm just getting some code that's disturbing me. The 4 oxygen hydrogen single bond, the energy given off when the 4 oxygen hydrogen bonds are made is as follows. All right, let's go. The 4 hydrogen, and then oxygen bonds. And the OH, right? 4 OH, the oxygen and hydrogen. Let's see. Hydrogen and oxygen, hydrogen and oxygen, hydrogen and oxygen, hydrogen and oxygen. Sorry for that. I was trying to calm down the phone. Somebody's calling me. And that's a group call, which is disturbing me. All right. So you see, let me use the case hydrogen and oxygen to form hydrogen and oxygen to form hydrogen and oxygen to form hydrogen and oxygen to form. So form hydrogen, oxygen, form hydrogen. So how much energy here? How much energy here? How much energy here? How much energy here? Then you put them together. All right. So that's what we are doing here. Yeah. So 4 of them, hydrogen, oxygen, 4 of them. That's the energy for that. So this is the total of it. All right. The total, that formation, and then this is the formation. All right. So then you find that when you combine the two, right, the breaking and formation. So the net will be negative 482 kilojoules per mole. That's the approximate energy that we needed to bond and then to form water. When you come here, you come to the chart here. They are all here. See, when you see hydrogen and oxygen, let me go down. See, hydrogen and oxygen, 463. So hydrogen and oxygen give you 463. If you're talking about oxygen, oxygen double bond, oxygen and oxygen double bond is 498. When you say hydrogen and then hydrogen, where is hydrogen? Yeah, 436. So all of them, they are on the chart. They bond energy of covalent bond. These ones, they are tabulated. If you go to the net, you find it there. They are there. If you take any chemistry book, they are in there, right? So these ones, you cannot determine carbon and oxygen. You are going to determine this bond, though, right? They are tabulated, so you can use them to do approximate. All right, so that's what we were doing here. All right, you use them, the bond breaking here and bond forming. The bonds are broken and then they are formed. Right, you break it first before you form it. That's how it is. That's the reaction that is going on there. All right. So, you break the hydrogen and hydrogen bond. All right, and then you break the hydrogen and hydrogen bond. Then you break the oxygen and then the oxygen bond. Now, once you are broken, then you form them here. Hydrogen and oxygen formation, hydrogen and oxygen formation, hydrogen and oxygen formation, hydrogen and oxygen. So this 1, 2, 3, 4, 4 of them. And here just 1 and 1, which is 2. And this is just only 1. Then you do that, then you find a net, and then the net will tell you, right? That's what we did here. So the net is, this one, the formation, the breaking, and then the formation. And then this is the net. All right, so delta H for this to form the water is actually delta H is negative 572 kilojoules per mole. So the answer is off by 60%. The one that we did earlier here, this one, right, is an estimate, right? You join the estimates like those who are in construction or in any other business, you call a mason or an architect. You say, please, can you come? I want to know estimate how many blocks that I'll use to build my house. All right. When a person comes around, the person can give you, cannot exactly give you how much you are going to use. He will estimate it for you. He will give you either more or less, right? But then when you build a house itself, that's when you know that, oh, okay, this is the exact amount that I use, amount of blocks that I use to build my house. So this one, so the one that we did is just an estimate here. It's just an estimate. But this is the actual one. When you do the experiment and you see that, okay, this is the energy that I use to do the breaking and then the formation. So when we did the estimate one on the top one, right? And the difference from the actual and then the estimate is just 16%, which is not that bad. I'm done with this slide. All right. And let me see the time that I have. It's 12:44. All right. So I'll close for today. One will meet next week. Next week is online. Hello.
Hello, sir.
Yes. Hello, guys. Who is asking a question? Somebody talking to me.
Please, if you want to talk, then kindly mute the background sound so that we can hear you.
Exactly. If you want to talk, there's another thing that is going on at your background. If you are watching a TV or whatever, turn that thing off. Because we don't stay, when we come online, we didn't stay that long. We just stay for only maybe 1 hour, hour 20 minutes or so. So you just mute it and let's talk. All right. Otherwise, we cannot hear you. And one thing is, when you ask a question, it may be your friend's question. It may be a question that your friend wants to ask, but once you have asked, the person cannot actually ask the same question. So then, if your background is big noise, you cannot hear the answer that I'll give. Do you get it? So please, let's mute our background when we are talking. For me, my family is out there. I'm in my room. I've locked the door so that nobody will come here to disturb me. And I'm doing my lectures. When I open my door now, you see those ones that I brought to the school. The way they will come and disturb me, you understand? So I just lock my door. So please, when we are doing this, just mute your background, okay? Or go and hide yourself somewhere. I think somebody wanted to talk, but who wanted to talk? Somebody wanted to talk to me. Nobody. All right, then God willing, next week meet, okay? Hello.
Hello, sir.
Hello, sir.
Yeah.
Yes, sir.
So next
Yes,
week
sir.
we meet. Yeah.
Please,
Sir, please.
Okay.
Okay, Charlie, go ahead.
I want to talk about the assignment because the email is not going through when I send it. It bounces back.
Bounce back. Okay, what you can do is this. You can send it to my personal email, right?
Okay, sir.
Look, you guys can send your assignment to my personal email. It's the same thing, just send it to B Asante. B Asante.
So that was what I was going to ask. If you can,
I'll check it through my email. basante@gmail.com.
Okay.
G Asante. No, hold on. G Asante Oh no, make it this way. Sorry. Asante B.
Sir, please,
Asante B.
sir, please, can you put it on the group that we created with you?
Yeah, I can put it there. But in the
Mm.
meantime, Asante B 683. Asante B. Asante B. Asante Asante B like boy B 683 at gmail.com. Did you get it?
Yes, Asante B
Uh-huh.
63
683.
at gmail.com.
Yeah, simple. Asante B 683 at gmail.com. But I'll put it on the WhatsApp platform as well. All right. So then you can send me your homework through that place. It's just for me to receive it. All while we are talking, is for me to receive your homework and see the work that you have done so I can give you a grade for it. Do you get it? Uh-huh. So then the only means that I can get is what we are talking about here. It doesn't matter whether we have this platform and it's not working, whether it's working or not. Even if it's working, I have to receive it anyway. So you just send it to my email and then I will look at it. All right.
Okay,
Any
sir.
other issue or any other thing that you want me to know? Otherwise, I'm going to spend the rest of my weekend. Tomorrow I have to go to church. So I have to go and prepare and go to church tomorrow. All right. Today I didn't hear about your class rep. Class rep, are you there?
No, sir, he's caught up with some issues and
What kind of issues? Is it
um,
because I didn't hear
some
class rep.
emergency issues. So
What kind of emergency issues? What kind of emergency issues? Me, I knew he won't come because the way you started calling, I knew he won't come.
Yes, I am wearing the shoe today. I'm putting.
Me, penny no being a bit and yakola. Me, the time you started, I realized that things will not come. Anyway, I see you guys. Any issue, just call me. All right. I'll see you guys next week. God
Okay,
willing.
sir.
Sure.
Thank you very much.
You're welcome. Sure.
All right, class. Our next lecture will be the subject is engineering technology, and it will start at 1:45.